Welcome, everyone. Let's start with a scenario we all know too well. You pick up your phone to check a single notification, maybe a text or a calendar reminder. But then, almost unconsciously, your thumb taps a social media icon. 40 minutes later, you're deep into a video about the history of 1920s toaster restoration, or a thread about a niche conspiracy theory. How did that happen? Was it a lack of willpower, or was it a masterpiece of engineering? Today, we're peeling back the curtain on social network analysis, or SNA. This isn't just about coding or data. It's about the high-stakes intersection of graph theory, human psychology, and artificial intelligence. We are going to explore the invisible mathematical hand that shapes your digital reality. By the end of this hour, you'll understand that you don't just use the feed calculates you. Welcome to the engine behind the feed. To understand the math, we have to understand the why. Let's be real. Social media companies aren't connecting the world out of pure altruism. They are in the business of attention. I want you to think of yourselves as digital oil. In this economy, you are the raw material being harvested. The North Star metric for every engineer at Meta or TikTok is retention and dwell time. Every single second you spend staring at a post, even if you don't like it, even if you hate it, is a win for the algorithm. The revenue model is simple. Time equals data equals ad value. If a developer can tweak a line of code to increase your average session by just 10%, that translates to billions of dollars in revenue across a global user base. In this room, you aren't just users. You are the product being meticulously harvested. Why is it so hard to put the phone down? It's because the app is designed like a Las Vegas slot machine. It follows the hook model. It starts with a trigger, maybe a ping on your phone or just the internal itch of boredom. You take an action, the infinite scroll. Then comes the variable reward. This is the genius part. If every post was amazing, you'd get bored. If every post was bad, you'd leave. But because the reward is variable, sometimes a boring ad, then bam, a funny meme or a photo of your crush, you stay addicted to the pull. This is fueled by FOMO, fear of missing out, the anxiety that if you stop scrolling, you're missing a moment. Now let's get into the math. Imagine the entire internet as a chaotic ocean of billions of nodes. Every post, video, and ad ever created. Your phone screen is just a tiny window. How do you fit an ocean through a window? The algorithm acts as a mathematical projection. Think of it as a massive filtering funnel. It runs a scoring function on every available piece of content to calculate the distance between that post and your specific interests. Out of billions, it retrieves a, quote, top 20 feet list designed to stop your thumb from moving. To truly understand this, I want you to act like data detectives. We are going to perform reverse engineering, taking the results we see and working backward to find the logic of the engine. To predict your behavior, the system relies on 3 pillars. First, the user vector. This is your mathematical identity, a list of numbers or coordinates that describe everything you've ever liked. Second, the content vector. What is this post actually about? Is it technical, funny, or political? And third, the social graph. This is the topology of your life. Who are your friends? Who do they follow? The algorithm constantly cross-references these 3 pillars to find the golden post that fits your current mood and your social circle. Let's look at the structure. In our graph, we have nodes, people/entities, and edges, the connections. But not all edges are the same. Directed edges are like Twitter or Instagram. I follow a celebrity, but they don't follow me. +1. Dove, you asked what directed means exactly? It means the interest flows in one direction, like an arrow. This allows one node to be a hub for millions without needing mutual approval. Undirected edges are mutual, like a Facebook friendship. But the most important concept here is weighted edges. Think of this like a city flight map. Some connections are just 0 or 1 foot. Either a flight exists or it doesn't. But in social networks, edges have a value or intensity. A connection to your mother is a heavy line in the graph compared to a guy you haven't seen in 15 years. The algorithm always prioritizes the heavy lines. How do we find the main characters in a network? We use metrics. Degree centrality is simple. It's the prom king, the node with the most connections. Betweenness centrality is more interesting. These are the gatekeepers. Imagine me, the lecturer, and you, the students, as 2 different communities. The head of the department acts as the bridge between us. Without that bridge, information cannot flow between groups. Finally, clustering coefficients identify cliques, tight-knit groups where everyone knows everyone. If your neighborhood is dense with crypto content, the algorithm assumes you'll never want to see a post about knitting because it's too far from your click. The graph isn't just a list of humans. It's heterogeneous, meaning it's made of different quote-unquote species of nodes. You have people, yes, but also creators, brands, and digital assets like websites or posts. Plus two, even physical locations are nodes. If you check in at a gym, or even if your GPS just stays there for an hour, you create an edge between a user node and a location node. The algorithm now knows you're into fitness, not because you said so, but because of the geometry of your graph. This is where we get into Black Mirror territory. Platforms maintain an invisible graph of shadow entities. You probably ask yourself, how do they know me if I don't have an account? They build a shadow profile based on things connected to you. They see your number in a friend's WhatsApp contacts. They use tracking pixels to follow you on external websites. It's like a shadow that follows your data. They even use passive geolocation. If our phones are in the same room for 2 hours, the graph assumes we are friends in real life, even if we never follow each other. The visible app activity is just the tip of the iceberg. How does the machine know you really liked something? It uses weights to measure interaction strength. A like is cheap. It's the lowest form of engagement, worth 1 point. A comment takes more effort and is worth 3 points. But a share? That's the holy grail, worth 5 points. A share is you telling the world this content is valuable. The formula where the system sums weights multiplied by actions is how it calculates the total interaction to decide how bright a post should glow on your screen. We have to look deeper than just clicks. In this world, an edge represents a total relationship bond, not just a one-off interaction. Think of it like a layered connection. On one hand, we have structural ties, which are your long-term foundation, like family members or old-school friends. These are the constants in your life. On the other hand, we have communication signals, the dynamic pulse of the graph. This involves DMs and tagging. If you DM someone, the algorithm immediately moves them to the top of your feed. Why? Because a DM is a strong tie. Passive likes, those things you do while half asleep, are weak ties. Who are you to the algorithm? You aren't just a name. You are the fusion of two distinct maps. The network map is where you sit in the world. It is your neighborhood of friends and social connections. Then there is the semantic map, which tracks what you actually like, the topics and meanings of the content you consume. Sometimes these maps clash. Your friends might all love football, but you personally love poetry. You sit in a football neighborhood, but your heart is in the poetry cluster. The algorithm's job is to find the sweet spot that satisfies your social obligations to your friends while scratching your personal itch for content. Every user sits at the center of their own ego network. Inside this, we use community detection to find your tribe, that group of people you share the most edges with. This is why you might see a post just because 80% of your immediate circle watched it, even if you don't follow that creator yourself. The algorithm assumes if the tribe likes it, you probably will too. It's guilt by association, but for digital content. This slide is the heart of the user vector. You are literally the average of what you eat, digitally. Every single post you consume, whether it's a news article, a science documentary, or a music video, is represented as a vector that gets added to your profile. Over time, this creates a single, high-dimensional arrow, your user vector, pointing toward your personal interest galaxy. This isn't just a static list, it's a living coordinate in space. Think about it. If you spend a whole week watching nothing but cat videos, the math doesn't lie. Your mathematical me starts pointing straight at the 90% cat cluster. The algorithm doesn't care who you say you are. It cares about the average of where your clicks are taking you. But what if you get bored of cats? That's where vector drift comes in. Does my vector just get bigger as I like more things? Not exactly. It doesn't just grow in magnitude. It changes direction. Think of your identity as a ship drifting in space toward a new location as your interests shift. The alpha in the formula is the learning rate. If alpha is high, the feed reacts instantly to your new clicks. If you click on one golf video and suddenly your whole feed is golf, that's a high alpha. The algorithm is aggressively trying to keep up with your changing tastes. Imagine a 3D galaxy where every piece of content is a star. This is the latent space. What this actually is, it's a mathematical space where everything, videos, posts, comments, is turned into vectors with thousands of dimensions. Each dimension is abstract, making it hard for humans to define, but the computer knows that points close together share the same DNA or meaning. It understands your semantic neighborhood, even if the words are different, mapping distance directly to your intent. How do we measure social distance? We use the Cosine Similarity formula. It looks at the intersection of our friends divided by the union of our friends. If we have 10 mutual friends out of 20 total, our proximity is 0.5. That's a huge signal to the algorithm. This creates the bridge between nodes in the graph. A first-degree connection with high interaction always gets signal priority, which is why your neighbor's boring vacation photos often appear before a viral video from a total stranger. How does the computer compare two vectors? It doesn't look at how long they are. It looks at the angle theta between them. This is cosine similarity. If the angle is 0 degrees, you and the content are perfectly aligned with the same DNA. If it's 90 degrees, you have zero interest. The algorithm is constantly trying to minimize this angle to ensure everything you see matches your identity. His is the final boss of the lecture, the equation that runs your life. Raphael, you asked, is this just the function for what appears first? Exactly. The score is basically social proximity multiplied by vector similarity, all divided by temporal decay. It combines three factors, plus 3. Social proximity. How close is the creator to you in the graph? Vector similarity. How much does the content match your DNA in the latent space? Temporal decay. Is it fresh or stale? The post with the highest score wins the top spot in your feed. Platforms just tweak the weights in this master function to create a different vibe. Facebook is social heavy. It prioritizes who you know. TikTok is semantic heavy. It cares about satisfying content, even from total strangers. X, Twitter, is decay heavy. If a post is 5 minutes old, it's practically dead to the system. They all use the same math, just with different volume knobs for each factor. In the end, it's a giant loop. Your action leads to an algorithmic update, which generates new content, which then influences your next action. Plus 3. The danger is the filter bubble, where the algorithm gets so good at guessing you that you never see anything new or challenging. Remember, you aren't just a user. You are a moving coordinate in a multidimensional graph. To wrap up, the feed is a mathematical projection of the graph. You are a data point moving through this space. Every click recalculates your score in real time.